We've been discussing the correlation coefficient R and have talked about how R gives you information on both the strength of a linear relationship between two quantitative variables, but also how it gives you information on direction. So the direction is implied with the sign of the correlation coefficient, and the strength is indicated by the magnitude. Today we're going to talk about a value called R squared. So it is the value of R, but instead of just using R, we're going to square it. So because of that, because of the nature of squaring, we're going to lose information on direction, but retain information on strength. In order to interpret R squared, you'll talk about the x variable and how much or what percent it explains in the observed values for y. So R squared generically will be stated as the x variable. Remember, that's the variable on the x-axis. Explain R squared percent of observed variation in the y variable. So generically, that's how you will interpret. Now we are going to first calculate R squared for age and distance to read a highway sign. So remember that the correlation coefficient was equal to negative 0.8, and so if I were to square that value, I would come up with 0.64. So that's my value for R squared. So when I interpret this value, I'm going to say age, because that's my x variable, explains, and then I'm going to transition that R squared value that we just calculated into a percentage, so it would be 64% of observed variation in distance to read a highway sign, or in distance. Now, it's always the x variable that's doing the explaining, and that should make sense because the x variable is also called the explanatory variable. And then it's also important to remember that we're discussing observed variation in the y. So we have both observed and predicted values for y. The predicted values are going to be coming from our regression equation. So here, this measurement is specifically referring to the observed variation.